Hey guys, this is Chelsea, and this is the Intro to Robotics Robot Project number 1. And this is Objective 1. In Objective 1, my goal was to build a basic Mazebot. I have 2 VEX DC motors, a VEX battery, and an Arduino shield. Here's a list of other materials that was needed to build the frame. I originally had 2 big gears driving 4 small gears, but I figured out I needed more torque to turn the Mazebot instead of speed. So I had to switch my gearing system with 2 small gears driving 4 big gears. In code, I have included the servo library, and I'm declaring that I'm using 2 VEX DC motors. In void setup, I have DC motor 1 attached to pin 10 and DC motor 2 attached to pin 11. And then come down here to void loop. The robot will drive forward for 1.5 seconds. So I have DC motor right 120 and DC motor 2 right 120. So that these values mean the motor will be forward for 1.5 seconds. And I have drive the robot counterclockwise, which is a left turn. So DC motor 1 will be at speed 40, while DC motor 2 will be at 120. And it'll make the left turn for exactly 1 second. Drive the robot forward again. Both the DC motors are at speed 120, and they'll be driving for 2.2 seconds. And it's going to make a right turn. So the DC motor 1 will be at speed 120, and DC motor 2 will be at 40 this time, and it'll turn for 1 second. And drive the robot forward again, 120 for both motors for 7 seconds, and make another right turn. DC motor 1 will be 120, DC motor 2 will be 40, and it'll turn once again for another 1 second. It'll go forward again, and then it'll stop. Once it's done going forward for 3 seconds, it'll stop. And this is the speed at its stopped motion. And while true, it means the robot will finish all the commands if this statement is true. So it goes forward, left, forward again, and it turns clockwise, which is a right turn, and then it goes straight for 7 seconds. And then it makes a right turn again, and then it goes out the maze going forward. In Objective 2, my goal is to use a VEX push button to stop the robot from going forward when the button is pressed, to reverse the robot and make it turn clockwise or counterclockwise, left or right. Once the button is pressed and the robot has reversed, it will continue throughout the maze. I have attached a VEX push button in the front and a VEX LCD monitor on the side. Even though I'm using a VEX LCD monitor, I can't get any values to display, but it's supposed to read the push button values and if the robot is going forward, reverse, left, counterclockwise, or right, clockwise. Code, I have included the VEX library this time and also the servo library. I'm declaring that I'm using a LCD variable, and I'm also declaring I'm using a left and a right motor, and I have another variable which is declaring the value of the push button when the motor is running going forward. In void setup, I have still my basic setup of the motors. They're both still attached to pin 10 and 11, but I have included my LCD, which should display, but on mine it doesn't. But I have initializing the LCD display and clearing the LCD of any previous programming, and then this display next LCD string, it's supposed to actually display robot start, and it has a delay of 1 second, and then clears clears it again so I can move on to the next string I want to display. And I have a push button here in pin mode, and I'm using a input pull-up resistor, and it's attached to pin 2 on my digital side. Come down here to void loop. I have push button value equals digital read 2, so it checks the value of the push button. And I have a while statement this time. Instead of using timer delays, I have while statements for going forward. So push button value equals high. That means if the push button is not pressed, the motor will be going forward using values of 120. Those are the values of going forward. And if my LCD monitor did work, it was going to display, it's going to use display next LCD string chalk spot forward, and then it was going to display the value of the push button. And it come to break the while loop, the button has to be pressed, and then it's going to reverse. So it's going to read the push button value again, and then it's going to reverse using the values of 20, and I have a delay of 0.3 milliseconds. That means it'll when the button is pushed and it reverses, it'll reverse for 0.3 milliseconds and then stop, and then go to the next command, which is my left turn, my counterclockwise turn. And it'll have the left motor going at speed 40 and the right motor going at 120, and it'll complete the turn in 1.1 seconds. And I have another while loop for it going forward. After it breaks the while loop, the button will be pressed, and it'll reverse for 0.2 seconds, 2 milliseconds, and it'll turn clockwise. So make a right turn using, on the left motor it'll be 120, and on the right motor it'll be 40, and it'll turn for 1.1 seconds. And then I have it going forward again using another while loop, stopping and reversing using the push button. But in this one, it'll reverse in 0.7 seconds, and then it'll make another right turn, left motor going 120 and the right motor going 40, and it'll make the left turn in 1 second. It'll make another while loop going forward, break that while loop using the push button, and it'll reverse in 0.2 seconds, and then it'll stop once the button is pushed. And here's my values for it being stopped. The 90s are used for when the motor is stopped, and then I have another while loop, meaning the while loop command. This while loop command will be true until all the other commands above have been completed. The Mazebot goes forward, push button gets pressed, it reverses, turns counterclockwise, goes forward until push button is pressed again, then reverses, makes a clockwise turn, goes forward again until the push button is pressed, then reverses and makes another clockwise turn, and goes forward again until the push button is pressed, and then the motor